Here's the video of review 2. So, like I said, a quick way, if you have the Desmos calculator, instead of plugging each value in here, just go to the gear and then hit the table, and that will give you a table of values. And then what's the inverse function? So the last thing we did was subtract 1. So the inverse is going to be add 1, and then the inverse of cubing would be the cube root. So the cube root of x plus 1, so we'll call it g of x, equals nth root. So the cube root x plus 1, and then minus 3 on the outside of the radical. And it looks like that. And then to get the inverse table, once again, go to the gear, go to the function you just made, and you should be able to see like -2, 0 down here is 0, -2, -1, 7 should be 7, 1 down here. So if I plug in a 7 or 7, -1, -1, 7 becomes 7, -1, 26 should be 0 down here. So, all right, so we can see, or to get the inverse table is just swap the x and y's, and you'd get the inverse table down here. The second slide, once again, to find a table, hit the gear, and then hit the table next to the function, and you'll get the table. So -2 is 0, -1 is 3, 0, 8, 1, 15, 2, 24. You almost got all of them except for -3 and +3 there. And then the inverse function, once again, let's call it g of x. X. And then when you go up here, the first thing we're doing, the inverse is add 1 and then take the square root. So this should be square root of x plus 1 and then -3. And the inverse table, just hit the gear, come down here, hit the table, and -2, -2 wouldn't be on, so it should be -1 should be the first point here. So -1, -3. All right, 0, -2. And 15, 1 should be. And 24, 2. -2 is undefined right here because we're just on this branch here. As for the inverse, all right, let's find the solution here. So first thing we're doing is subtract 6, and then you have -3 equals square roots of x plus 1, x plus 2. And then the next step, someone asked me another in one of the classes why I put a semicolon. I'm just a semicolon between steps. Right here, you can see that there's not going to be an answer. So square root of some number equal -3. It can't be true, but let's go ahead and finish. So square both sides. And then x is 7. I plug that back in here. 7 plus 2 is 9. Square root of 9 is 3. Plus 6 is 9, not 3. So there's no real solution here. And then number 2, subtract 7 first. And then square both sides. And then add 2. X is 6. And then if I try that, 6 minus 2 is 4. Square root of 4 is 2 plus 7 does not equal 2 plus 7 is 9, doesn't equal 5. So no real solution here. And then subtract 1, you have -1 equal the cube root of x plus 1. And then cube both sides. -1 equal x plus 1. Subtract 1, -2 is equal to x. And we'll plug it in. -2 plus 1, -1. Cubed is -1 plus 3 is 2. So that one works. And number 4, subtract 3. You have -1 equals nth root. So cube root of x minus 3. Notice that I picked 2 and 3 there. I should have picked a different number, but this is very similar to number 3. And then cube both sides. -1 equal x minus 3. And add 3, x equal 2. And if I plug that back in, 2 minus 3 is -1. Cube root of -1 is -1 plus 3 is 2. What's the average rate of change here? So when x equal 1, y equal 4, and when x equal 9, y equals 12. So you have these 2 points, 1, 4, and 9, 12. So this, using the slope formula, or rate of change, 12 minus 4 over 9 minus 1. That's equal to 8 over 8. Which equals 1. Okay. And then this one, when x is 8, the cube root of 8 is 2 times 3 is 6. Y is 6. And x equal 27. Y equal 9. So 8, 6, and 27, 9. So 9 minus 6 over 27 minus 8. So 3 over 19. I don't think I changed that. That one didn't change from the last review. So I think that's the same problem. 3/19. Number 7. This can't be simplified. This one is a to the 5th b cubed. This one's a6 b 4th. So that one's a to the 5th b cubed. These two are the same. A to the 5th b cubed. That one's the same also. This one is x squared y squared. This one's x squared y squared. So these two are equivalent. This one is not. Can't simplify that. X squared y squared. So this one is not equivalent. And we did this one in class. So 2 to infinity, 1 to infinity. How did I get that? You went to the calculator. So I used the graphic calculator on this one, but the main range is going to deal with the endpoint here. The endpoint is 2, 1. And then f of x equals square root of x minus 2 plus 1. And then the domain, as I go from left to right, the first place I see a point is 2, so 2 to infinity. And then the range, bottom, first place I see a point is 1, so 1 to infinity for the range. So 2 to infinity includes 2 for the domain, 1 to infinity includes 1 for the range. And this one also did in class, so negative of the square root of x plus 2. So I'll make this a negative square root of x plus 2 minus 3. So this one is a decreasing square root function. So going from left to right, negative 2 to infinity, the bottom, negative infinity to negative 3. So -2 to infinity, -infinity to -3. And we did this one in class. Which of the following statements are true? In one of my classes anyway, and I didn't know all of them. So which of the following statements are true about all exponential functions? The domain of an exponential function is all real numbers. The graph always has, exponential function always has an horizontal asymptote, and the graph of an exponential function always has a y-intercept. 13, you take a logarithm and change the exponent. So this is a base exponent number. So this would be 3 to the 4th equals x. This one is 4 is the base. The exponent is 2. 4 squared equal x. This one is 5 exponent x equal 25. And here x exponent 3 equal 8. And then this one, here's the model b of t equal ab to the t. So a is the initial value. And that's 300. So b of t equal 300. The multiplier is 2 doubles. 2. And then exponent t over 30. All right.